Okay, class. Another method to find or to determine maximum and minimum point is a Lagrange multipliers. Okay, so before this we have discussed about apa tadi tu, about relative maxima and saddle point. So now we have another method which is Lagrange multipliers. Okay, so the difference between relative maxima and Lagrange multipliers is in Lagrange multipliers we do not need to test on the second order partial derivative. We just apply for the first order partial derivative. Okay, where in relative extrema we need to apply, or we need to use second order partial derivative to determine whether the surface has a minimum point, maximum, or saddle. Okay, so now look at this one. Lagrange multipliers is a method in finding the local maxima and minima of a function subject to equality constraint. In example, subject to the condition that one or more equations have to be satisfied exactly by the chosen values of the variable. So the basic idea is to convert an constraint problem into a form such that the derivative test on an unconstrained problem can still be applied. Okay, so in theorem 13.15, it is explained to us the condition for the existence of such multiplier. Okay, so now look at this theorem. So this is about Lagrange theorems. So let f and g have continuous first partial derivative such that f has an maximum at the point x0, y0 on a smooth constant curve g equal to c. So if gradient of g does not equal to 0, then there is a real number lambda such that gradient of f equal to lambda gradient of g. So the meaning of gradient here is it is about a first order partial derivative respect to x and y on f, and a first order partial derivative respect to x and y on g. Okay, alright. So this is a Lagrange multipliers. So again, untuk Lagrange multipliers, usually we will apply or we will use if we have ataupun if we want to find local maximum and minimum with a constraint. Okay, so constraint subject, dia ada lagi satu surface lah ataupun plane. So let's say look at this diagram ataupun this figure. So in the blue one is our surface, and this surface contrasts with another object which is this plane. Okay, yang nampak hijau tu adalah plane. Alright. So in this case, it is cuba ataupun lebih sesuai untuk kita gunakan Lagrange multipliers. Okay, so now the scalar lambda is called a Lagrange multipliers. So apa yang dikatakan Lagrange multipliers is this one, scalar lambda. Okay, so this theorem will be used in the method of Lagrange multipliers in finding the extremum values of a function f subject to a constraint. Okay, so now look at this method of Lagrange multipliers. Let f and g satisfy the hypothesis of Lagrange theorem. Then let f have a minimum or maximum subject to the constraint g. To find the minimum or maximum of f, use these steps. So here we have a two step. The first step, we need to solve simultaneous equation for the gradient ataupun for the difference of f equal to lambda gradient of g ataupun difference of g. And the constraint here is this one, g. Okay, so in this step, we need to set up for these three equations. Okay, so the first equation, it is about first order derivative respect to x on f and g. And the second equation, it is about first order partial derivative respect to y on f equivalent with lambda. So lambda is a Lagrange multiplier. Multiply with first order derivative respect to y on g. So this is our second equation. And the third equation here is, this one is a constraint object. Object yang lain lah selain daripada surface. Okay. So after we set up these three equations, then we need to evaluate f at each solution point obtained in the first step. So the greatest value yields the maximum of f subject to the constraint G, and the least value yields the minimum of f subject to the constraint G. Okay, so in this step, dalam step yang pertama ni, after we set up these three equations, then we need to solve simultaneous equation. You solve to find values of x and y. Okay. Maknanya dekat sini you dapatkan nilai x and y and you will have the possible point. So possible point, nak cari point dia tu di dalam step yang inilah. Alright. Faham tak? Tak jelas So kita tengok example. Okay, look at this example. Example 10. Using a Lagrange multiplier with one constraint. Okay, so the question asks you to find a maximum value of a surface fxy where y is greater than 0 and x is greater than 0. Okay, so subject to the constraint is this one, x squared over 3 squared plus y squared over 4 squared equals to 1. Okay, so first, as a solution, first step we need to set up for three equations. So how to set up? It is based on this one lah. Okay, so first we need to find the first order partial derivative respect to x and y on f and g. So here we have for y, for the first order derivative respect to x on f, and we have for x for the first order derivative respect to y on f. Okay, and then gx we have 2x over 3 squared, and g sub y here is we have 2y over 4 squared. Okay, so this is our constraint. So first we set up for first order derivative respect to x. So here we have 4y equals to lambda 2s over 3 squared. And the second equation, we have 4x equals to lambda 2y over 4 squared. And the third equation, it is about constraint. Okay. And then solve a simultaneous equation from 1. So from this one, we have 4y equal to lambda 2x over 3 squared. So the Lagrange multiplier here is 36y over 2x. Okay, so this one we substitute into second equation. This one, you masukkan nilai dia. And you will have this one. Okay. And next we find value for y. So y here is 8. So 8 kat sini dia ada positif negatif lah. And y to the power of we have positive, negative, third y, third x, third 8. Okay. So we have this one. So y have two values. Satu positif, satu negatif. Tapi awal-awal dia dah kata apa? Y is always positive. So y is 2 third 2. So this is a value for y. Okay. So next x squared. So kita cari nilai x. So x pun ada two values, positive and negative. So since x is always positive, so the value of x is 3 over 2. Okay, so therefore the possible point here is 9 over 2 and 2 third 2. Kalau ada lebih daripada satu nilai, so you will have more than one possible points. Okay, so now we find the value of the surface with the obtained point kat sini. You masukkan dalam ni dan you akan dapat 24. So this one, f of x kita apa tadi? The function here is for xy kan? Okay, so you masukkan je nilai dia. or XY. So point dia kat sini 3/2. Betul ke ni? 3/2. Yes. Jadi kat sini ada set ada square root kat situ di sini. Okay. Alright. So ada 24. So the value of this point is about 24. So this one dia suruh cari maximum point kan dalam kitab kat situ. So the maximum point here is 24. So Lagrange multipliers is more simple compared to relative maxima. Okay, so ini je untuk Lagrange multipliers. Okay, any question class?
Tak ada.
Tak ada. Alright, so you boleh buat a passing question. Mana? Ni yang dekat Jun. Tak pun buat dalam buku teks pun lagi bagus lah. This one, question 8. Okay, so relative ekstrema. Kita perlu gunakan second order partial derivative to test the discriminant. And untuk yang lain, December 2019. Ni ni pun relative ekstrema. Okay, boleh buat. So markah dia memang agak besar lah. 10 to 12. 8 paling sikit pun 8 markah. Okay, boleh. So nanti saya akan share tutorial. Dia ambil soalan daripada textbooks and then kita discuss. Okay, so that's all about chapter 3. So chapter 3 is more on a function which involve more than one variable. Okay. Alright, so dalam chapter 3 we have apa kita ada? Kita ada higher order partial derivative, and then we also have chain rule, total differential, implicit differentiation, extrema yang tadi, and then Lagrange multipliers. Yeah. Okay, so all these are applied in chapter 3. Okay, so untuk chapter 3 ni, you kena betul-betul faham berkenaan dengan partial derivative. Okay, so if you have a problem about partial derivative, you might be a problem in solving in chain rule apa semua, you akan ada problem dekat situ. Okay, so the key in chapter 3, it is a partial derivative. So kalau ada soalan tentang partial derivative, you boleh tanya saya. Jangan malu. If you want to make a discussion slot about partial derivative pun boleh. Just mention and then kita set. Okay? Boleh? Alright. So okay, good. Alright, so this week saya tak dapat nak buat klinik match untuk hari Jumaat. Kata you nak buat hari Khamis, kalau you free boleh you just bagi tahu dalam group dan kita akan set. Macam last week kita buat Khamis kan. Jumaat ni tak boleh sebab saya ada meeting. Okay? Boleh. Alright. Okay, right. So ada soalan tak untuk chapter 3? Tak ada. Tak ada. Jelas Okay, so ini semua boleh dapat A ni. Alright. Okay, InsyaAllah. So, Amin. Okay, so kalau tak ada apa-apa soalan, I think that's all for today. So nanti saya akan share apa tutorial yang kita perlu buat Saya akan cari soalan dalam textbooks nanti. and then kita discuss dalam mathematics slide. Alright? Okay, so okay guys, so stay healthy, jaga kesihatan, jaga diri.